All right, so here's a common type of question at this point. Which of these would we expect to be more acidic?
The bottom one?
That's correct. This is more acidic. And how can we explain why that is?
Because when they get deprotonated, they're both going to have the O- over there, which will be stabilized via resonance. And then the fluorines are electron withdrawing, so they pull electrons toward themselves, making the carbonyl carbon more electrophilic, making the whole thing more acidic.
Okay, that's good. That's a good explanation. We might polish that off a little bit, but you got the basic ideas. That's right. Now, one of the most important things you did is, in order to explain which is more acidic, you didn't explain that in terms of the original molecules, you explained it in terms of the conjugate bases. That's the technique we were just learning. Usually you explain acidity not in terms of the acid, but the conjugate base. Now we know that both of these protons can be taken because this negative charge is stabilized by resonance, but there's an additional factor that's also stabilizing this negative charge. Remember that anything that spreads the negative charge out will help to stabilize it. Well, are these fluorines pulling the negative charge towards themselves or pushing it away from themselves?
Towards.
Yeah, they're pulling it towards themselves because they're electronegative. That's pretty much all the explanation we need right there. We don't need to get into any more detail about the effect on the carbonyl carbon or anything like that. It's good enough to say these fluorines would pull the negative charge towards themselves, which is away from where it is. So it's not going to be just stuck on this oxygen, it's getting spread over the rest of the molecule. We can't show that by resonance. That's what's called stabilization through induction. That would be an induction effect. So in addition to the fact that this is stabilized by resonance, both of these are stabilized by resonance, this is also stabilized by induction. Maybe we'll get more points in our answer if we use that term here. Both of these are stabilized by resonance, but only the bottom one is stabilized by induction. And the induction effect is how the fluorines are pulling the negative charge towards them because of their electronegativity. Okay, so electronegative elements also make something more acidic. So is it better for an acid to have more electronegative elements or fewer?
More.
Yeah, the more it has, the more they're going to pull the negative charge towards them. So if there's only one fluorine here, this would not be as acidic. And is it good for the electronegative elements to be close to the negative charge or far from it?
Close.
Close, because if they're too far to have an effect. So in general, something is more acidic if the conjugate is stabilized by resonance, and something is more acidic if it has electronegative elements, and it's more acidic if it has more electronegative elements, or if the electronegative elements are closer to where the negative charge would be. Finally, what about if we just put chlorines here instead of fluorines?
Chlorine will be more, but chlorine will still be.
Yeah, the chlorines would not make this as acidic because they're not as electronegative. Okay.
He has an exact problem on the exam.
Right.
It's that one, and then with chlorine.
Yeah. All right. So those are the exact issues you can expect to see.
He also said, though, in the exam, something that we didn't really understand.
That's a about the other exam. Yeah.
Oh, okay. Well, it was this problem. It says rationalize in order toward addition to the carbonyl by a nucleophile,
right,
which basically means like the most acidic to the least acidic.
Actually, this is a slightly different issue.
Oh, okay.
Yeah. All right.
So never mind.
Okay, but we'll probably get to that in a couple of minutes.